In this video, we are going to talk about atomic weight. We're going to talk about where you find this on the periodic table, and if you needed to, how you would go about calculating that number. Okay, so the atomic weight, this is different than the mass number. The atomic weight is the weighted average mass of all of the naturally occurring isotopes of the element. Remember that the mass number is for a specific isotope, so it's for one. The atomic weight is for all of the different isotopes all combined together, and they're weighted based on how abundant they are, how they occur in nature. As we step through the calculation, it'll be in a couple of slides, and I'll show you how to find this number on the periodic table. The biggest occurrence, so the most abundant isotope, will have the AMU closest to that mass number, and I will show you what I mean by that. So on the periodic table, the weight is going to be given to you underneath the symbol. So carbon's 12.001, nitrogen's 14.01. And in the previous slide, I said that the most abundant isotope is going to be very closely matched to the number on the periodic table. So in this case, for carbon, the most abundant isotope of carbon is going to be carbon 12. And for nitrogen, since that's 14.01, this is going to be nitrogen. Please forgive my handwriting, but nitrogen 14. Okay, so sometimes you can tell by looking at the periodic table and looking at that number what the most abundant isotope is. Okay, so here we're going to do an example on how to calculate the atomic weight when you are given percent abundances of each different atomic mass for each isotope. There are two steps to doing this. The first is to multiply the mass number by the percent occurrence in decimal form, and then you take all of those values and you add them together to get you the average atomic mass in terms of AMUs. All right, so the very first thing that I would do before anything else is to take each of the percent abundances and convert them to decimal form. And to do that, you literally want to divide each of those values by 100. So that gives us 0.7870. This gives us, dividing the next one by 100, 0.1013, and then dividing the last one by 100 gives us 0.1117. Okay, make sure those decimal places are nice and visible. Okay, so the next thing, once I have these in terms of decimal form, I'm going to multiply each of my atomic mass values, which are here, right, by the percent abundance in decimal form. So, and I'm going to do these each as an individual step. What you're going to see, this is going to be a little bit of significant figure calculation refresh. Here we're going to be doing multiple steps, so we're doing multiplication, division, and we're doing addition, subtraction. So I do want to make sure that I break this out so that I know how to apply the sig fig rules for each step. All right, so the first one I'm going to do is I'm going to take my atomic mass number of 24, and I'm going to multiply that by the abundance in decimal form. Now, the decimal, the percent abundance, has a total of 4 significant digits. So this is what I'm going to focus on for how many significant figures I can keep. So when I plug all of this in, rounded to the correct number of significant figures, I get 18.89. I want to do the exact same thing with 25. And again, my percent abundance has 4 significant figures. And so my answer here should have 4 sig figs, so it's 2.533. And then my last number, atomic mass number, is 26, and I'm going to multiply that by the abundance. And that gives me 2.904. Now you may be thinking, well, what about the atomic mass number? Shouldn't that be only 2 sig figs? Those numbers are going to be considered exact. So that's counting up how many protons and how many neutrons. So I do want to focus on the abundance as determining the sig figs, since that is a measured value. All right, so now that I have all of my values, I'm going to add them all together. So remember the multiplication, division, you are overall looking at the number of sig figs. For addition, subtraction, you are looking at decimal places. So if I add all of these together, I get 24.327. But because this first number right here only has 2 decimal places, my final answer can only have 2 decimal places. I'm going to be dropping this 7, which means I need to round this 2 up to a 3. So my final answer is going to be 24.33 AMUs.